بس ناخد صور عشان خاطر مش هنعرف نيجي تاني عشان الكاميرات الفيديو. اوكي
Ladies and gentlemen, we will start shortly, so please take your seats and would you please turn your mobile off? Okay. Okay. Dear Dr. Jens Brandenburg, Parliamentary State Secretary at the Federal Ministry of Education and Research, BMBF, and our guest of honor today. Dear Dr. Kai Six, General Secretary of the German Academic Exchange Service in Bonn. Dear Mr. Philippe Mopé, Science Attaché of the German Embassy in Cairo. Dear Dr. Ayman Saleh, Vice President of Ain Shams University. Dear Dean of Faculties, professors, academic researchers from the German and Egyptian universities, ladies and gentlemen. Welcome to the Egyptian-German expert talk towards COP27, challenges and actions to cope with climate change, water, and weather extremes in Egypt. My name is Ashraf Amin. I'm the head of the science desk at Al Ahram newspaper, and I'll be moderating today's event. This event is quite important for several reasons. First of all, in a few weeks, Egypt will be hosting the Conference of Parties on Climate Change, COP27, from the 6th to the 18th of November in Sharm el-Sheikh. An international summit that hopefully leaders of the world will agree on implementations to reduce greenhouse gas emissions and save the globe. Secondly, this year marks the 70th anniversary of Egyptian-German diplomatic relations and the 10th anniversary of the German liaison offices in Egypt. I am naming liaison offices of Freie Universität Berlin, University of Marburg, and Technical University of Berlin. All three offices have been working for over 10 years now on creating research networks between the respective universities and the Egyptian universities to facilitate mobilities between both countries and eventually initiate project collaborations. Today's event is a key example of this vivid cooperation, not only with Ain Shams University, represented by Dr. Mahmoud El-Metaini, and his team, who generously have been welcoming us to host this event today in this beautiful and state-of-the-art Innovation Hub campus. But further, there have been further cooperations with universities from all over Egypt. Thirdly, it's with no doubt that science is an illuminating channel to all countries who seek solutions to the current problems and a better future. With a challenging global crisis such as climate change, we all need the bright minds of the world to think of possible solutions to reduce greenhouse gas emission and limit global warming. That's why this networking is as important to the German researchers as it is to the Egyptians. And it should be considered an excellent opportunity to exchange ideas and best practices and to take things forward from the discussions today to come up with more research collaboration between Egyptians and German universities and also recommendations for the policymakers and the decision makers in both countries. Last but not least, the organizers would like to let you know that we are not only talking the talk, but also walking the walk. And we very consciously try to avoid any plastic materials or printout for today's event. For those of you who would need further information of the agenda and the program, just scan the QR code that you have on your tags here, and you would get all the details that you would need. We do know that this is really a small step towards a better and more sustainable future, but as they say, a journey of 1,000 miles begins with a step. Without further ado, allow me to introduce Professor Ayman Saleh, the Vice President of University Affairs for Graduate Studies and Research at Ain Shams University. Professor Ayman Saleh has been a key figure into turning this idea of this event into reality by being open to the idea of the liaison offices to create such a platform and facilitating everything to make it possible. Professor Ayman, the floor is yours.
Good morning, everybody. First, to express my my gratitude and happiness for having our German colleagues, and we are honored to have Dr. Jens Brandenburg, the Vice Minister of Research and Higher Education at the Federal Republic of Germany, and Dr. Six, who is the General Secretary of the German Academic Exchange Service, and also all the delegation from the embassy, and Mr. Philip Mopai, and Professor Dr. Lepper from the head of the AGIA. And I welcome the ex-ministers, Dr. Ayman Abu Hadid, Dr. Abdelawi Khalifa, the deans of our faculties. We welcome you all, professors and researchers from all over Egypt. First, I would like to announce that we are today celebrating 70 years of diplomatic cooperation or diplomatic relations between Egypt and Germany. This was reflected on the academic and research cooperation. We also congratulate our German colleagues because yesterday they celebrated, and with them we celebrated in the embassy the German Unity Day. So we congratulate for that. And first an idea about Ain Shams University history and pride. We claim that we were here 2,700 years ago because in the same district there was a university. Of course, it was demolished, but there was here 2,700 years ago a university. Its name was On. Again, this means the eye of sun. And then in 1950, Ain Shams University had the name of Ibrahim Pasha University. That changed to Heliopolis, and then to the final name, which expresses in Arabic the eye of sun, which is Ain Shams University. It's rather a small city rather than an educational research institution with over 200,000 undergraduate students, for more than 14,000 academic staff, academic programs more than 900. It's the third oldest Egyptian public university. These are our strategic aims presented, including innovation, scientific research, entrepreneurship, internationalization, capacity building, alumni career support, and digital transformation. We have 8 campuses, 19 faculties and institutes, 113 centers and units, 13 hospitals, 5 museums, 4 studios and radio stations. We have multiple joint and dual programs with different countries. This is our status regarding the international ranking. I would like to focus on the table on the right, where we internationally ranked as regard the SDG number 6 and the 82 as regard the 13th SDG. So it's a university that is trying to take care of the SDGs and the climate change and sustainability. This is the current number of Egyptians, researchers, students, professors in Germany currently. 31 students for their PhD degree, 9 for the postdoctoral positions, and 8 for master degree, 9 for others like training and joint supervision. This is the different universities where the Egyptian researchers are being trained or studying or cooperating. Germany represents the second most, as far as the number of research programs, the second important for Ain Shams after France, with 20 research projects. These are the name of some example of the projects that are taking place between Ain Shams University and different German institutes. The number of visiting professors and students coming from Germany, not now the mobility in the other way. Of course, in the years of the COVID-19, they were reduced to 9 in 2021, 5 in 21-22, with a total of 38 professors and students during the last years. We are looking forward for this to increase with the disappearance or of hopefully disappearing pandemic. We have 8 functioning agreements with German universities, but as we were discussing, our strategy or attitude towards cooperation with German universities and institutes is to plan for work, and we work. We don't wait for agreements, and this is even more fruitful. We have work when the work becomes big enough and wide enough in different disciplines, then we might think of an agreement. So we have agreements that's functioning, we are proud of, but at the same time, as you're going to see, we have much more activities with German universities than are within the frame of agreements. This is the university and the agreements. We have 2 agreements with Stuttgart and Ulm in engineering, and you've met some student and faculty with the program of urban design with Stuttgart. We have 2 with Leipzig, mainly concerned with the German language, Arabic language, the specialized translation. We had with the very active faculty of architecture and archaeology and heritage with Marburg mainly, and in the pipeline with Hamburg in the faculty of law, not yet functioning. The activities with the 3 universities who are sharing with us or co-arranging this meeting with us, the TU Berlin, it started 2019, extending the plan for 2025, extensive cooperation between the iHub, the International Department of International Affairs, the Iraq, the Career Center, with their counterparts in the TU Berlin. And the cooperation entails workshops, students and faculty mobility, research stay, summer and winter school joint modules. With Philip Marburg, the Center of Excellence for German and Arabic for non-native speakers, the exchange of students and staff through Erasmus mobility agreements, recent project in cooperation with the Faculty of Archaeology, in collaboration with the ISESCO, and as regards the Free University at Berlin, sustainable urban planning by establishing of an urban climatic labs in arid cities. This is integrated with IUSD that is already going on with Stuttgart. Arabic courses in Cairo at the Center of Excellence of the Ain Shams University, scholarships to attend the Free University International Summer and Winter School, and Erasmus Mobility in 2022. A glimpse at Ain Shams University activities regarding climate change. The international publications from Ain Shams University in general constitutes 16.9% of the Egyptian universities. As regard the climate change, the Egyptian international, let's say, production or publication is constitute 10.6% of the Egyptian universities in the climate change. One of the, just example, one of the ways to try to adapt and to mitigate with the climate change and to attain sustainability is digitalization of services and institutional activities. One of very important activities or establishment or achievement is the ASU to test, which is a digitized way of examining and evaluating students. Our target is to become a paperless university. Recently born, let's say, a couple of months ago, the Center of Excellence for Sustainability, which is planned to be the monitor of our own activity as well as to the international activities regarding sustainability. They are monitoring what's going on in the university, whether in the infrastructure or education or research, and sharing with other sectors of the university in planning the future for the infrastructure, for the education, and for the research. In Shams University campuses, we consider them, or they are acting as a living laboratory for sustainability. Just examples, the iHub, the building we are in now, it has a 42% energy saving rate, 44 water saving, and 62% saving in energy, and accordingly, it was the first Egyptian EDGE advanced certification in this building. The acoustic building at the Faculty of Engineering, it is a smart building. We are very much into the development of electric cars, and as a matter of fact, Ain Shams University is responsible for a national electric car racing every year, sharing international competition as well. We are trying to utilize solar cells as much as possible. And again, to the right is of the screen, it's a nurse, it's called Shams, referring to Ain Shams University, Shams, a robotic nurse that can comprehend Arabic and respond to the patients in Arabic language. to call for his doctor to deliver the medication and so on and so forth. And to the right side of the screen down, the self-automated electric car. In the upper left side, we have the small version of air wind turbine, where it said to just small one to be used in either a small building to generate electricity for the small building, or to be used in a remote farm in the desert, for example, where it can generate electricity enough for this small farm. We have down to the left the use of the palm trees and the palm midribs to produce wooden tables, and in the middle the Shams B Green, which is it's a prototype that the Faculty of Research in Environmental Studies has adopted, both as a prototype for the rest of the university and also as a way of education for the under and postgraduate, how to utilize the available water, the available resources, try to cultivate not in the regular soil. I don't want to talk much, so I just wanted to give you a glimpse of what's going on at Ain Shams University. I welcome you all. I am really privileged to have all this this audience of representing the German government, the DAD, the AGI, the embassy, and of course the three. We are privileged to have the three universities. Our dear professor, I thank you for giving the time and effort to be here. And I thank you, all of you, whether from Ain Shams or other universities. And I wish you a very fruitful day. Thank you very much.
Thank you, Professor Ayman. As I mentioned earlier, Germany and Egypt are celebrating this year 70 years of diplomatic relations. This occasion, but also the ongoing excellent relation between both countries in various areas, was already underlined by several visits between Germany and Egypt, of German government officials to Egypt and vice versa, and is being cemented by the visit of a delegation from the Federal Ministry of Education and Research. We're very happy and honored to have with us today Dr. Jens Brandenburg, the Parliamentary State Secretary of the Federal Minister of Education and Research. Professor Brandenburg, please.
Thank you very much, and good morning, dear Vice President, distinguished guests. I'm very happy and thankful you have us here. We are here on a 3-day delegation, a short trip to Egypt. It is my very first time to Egypt, and I'm really impressed what I can get to know so many people and places and strong research institutions as well here in this wonderful country. We've seen many things before in these 3 days with a small delegation from our Federal Ministry of Education and Research, accompanied by Dr. Six from DAAD, the German Academic Exchange Service, and Professor Lepper. Many of you probably know already, for example, in her position or her function as a representative of AGIA. And we've seen German University in Cairo, German International University had a good meeting with your minister, higher education, Minister Ashur. In the embassy, we saw many of you, and now it's kind of a grand final to be here at Ain Shams University. I'm really delighted. A very large university, actually, if you compare to many German ones. And I know there are so many cooperations between your university and Germany. And now this is kind of the final, within the final, to be part of this conference, or at least say some words to you on this conference on climate change. And I'm really thankful because I think this is one of the very most important topics we deal with worldwide in both our countries, but worldwide, one of the grand challenges of our time. And actually, I would say it's twofold. On the first hand, maybe it's about the question, how can we maybe not stop climate change anymore, but at least try to slow it down. There's the 1.5 degrees Celsius goal we politically agreed on internationally. And second, part of the title of your conference, how can we also deal with the consequences that climate change will have? And I think it's very good to have experts from both countries to work on this. We experience climate change. This is nothing theoretical sometime in the future. But you see it here in Egypt. We also see it in Germany. We had a very hot and dry summer. Not the first one, but we are having drier summers over and over again. And the climate change does have lots of consequences. Not only politically, it has social consequences, consequences in terms of migration, economy. So this is one of the biggest challenges of our time. And I think we will only be able to tackle this challenge if we have very close cooperation. Also cooperation between politics and science. Because politics alone cannot deal with climate change. This is a very complex issue. And in order to make good decisions, we need the best knowledge available from science. And also, science alone will not be able to deal with climate change because science alone might have the best knowledge, but cannot make collective decisions for people or even the world as such, a human being as such. And so I think it's really important to have both sides together. We should even communicate about this even more intensively in the future, I think. And now you have COP, here it is, COP27, hosted by Egypt in just a few weeks. And I think this is a very good opportunity to actually intensify this cooperation between politics and science even more. Well, but there's also a second dimension where I think we should cooperate, and this is international cooperation. And I'm really glad that this is a conference kind of organized by both sides. This is a big success actually of those universities, German universities with a liaison office here in Cairo. We had the chance, the opportunity to visit them at DAD House here in Cairo. It is the two universities from Berlin, technical universities and Free University, but also the University of Marburg. And I think it's really a big success that German universities meet in another country here in Cairo and actually start this idea of doing this together. And it's good to do this with Egyptian experts as well. Because as I said before, climate change is nothing we can deal with inside national borders. It is big questions. We are all concerned about climate and the air outside there doesn't really care about whether it's in Germany or in Egypt or somewhere else. It's really a global challenge. And we have serious issues with water supply, with energy. I was happy to learn that you have more energy here than we have in Germany. We currently have really serious issues with energy supply in Germany as a consequence of Putin's brutal war against Ukraine. This is something really putting much pressure on German economy and politics as such. You have a different situation here. So I think there are some questions how to deal with the next winters. We might cooperate together. But in the end, we need renewable energy. And we need to have an energy system and also a system of water supply that considers both climate change and the environment, but also the welfare of human beings. And these are big challenges. We can deal together. I'm happy you're here. Together. So let's continue this talk in the future between science and politics on the one hand, but also between German and Egyptian experts on the other hand. Be glad to be here, and I wish you a very successful conference, and looking forward to your results later. Thanks a lot.
Thank you, Dr. Jens Brandenburg, for this illuminating talk. And before having this short break, I would like to thank our guests today, Dr. Jens Brandenburg, Parliamentary Secretary of the Federal Ministry of Education and Research, BMBF, Dr. Kai Six, General Secretary of the German Academic Exchange Service in Bonn, Mr. Tilman Hochmuller, Deputy Head of the Mission, and all the members of the delegation. Thank you for being with us today. And a big round of applause for the colleagues here in Ain Shams University and the representatives of the liaison offices for doing this great work and organizing this event. So, a short break and we will start the science talks. Thank you. Let's say 5 minutes. 5 minutes, okay. نعم اعتقد شغال. طيب الساده الحضور استاذنكم بس تاخدوا اماكنكم و we will resume the science talks, so please take your seats, and if you could turn off your mobiles as well. So now we will be starting the science talks. For those of you who would like to ask questions to the speakers, السادة الحضور اللي عايزين يسألوا أي أسئلة, please scan the QR code, and you will find a tab called Q&A. You can write down your question and send it directly. And after each speaker talk, we will be raising the questions. And it will be, the same tool will be used as well for the panel discussion. So if you have any question and you want to address it to a special scientist or a speaker, just write down whom exactly you're addressing the question. Okay, so this is regarding the Q's and A's. Let's start now with our first speaker, Dr. Ali Nabih al-Bahrawi. Dr. Ali is a professor emeritus of water resources management at Faculty of Engineering and Shams University. Dr. Ali executed many national and international projects with organizations from Egypt, Canada, Germany, the United States of America, the World Bank, and many more. He has a vast research, teaching, and training experience in areas of water resources, hydropolitics, computer modeling, operation researches, education, soft skills, and intercultural communication. And Dr. Ali's talk will be about development and climate change in Egypt. So without further ado, Father Doctor.
I'm very pleased to talk to you today. My title is Development and Climate Change in Egypt. It doesn't work. I hate this. Yes, Egypt is working on climate change at different levels in preparation for the COP27, as mentioned before, to be held in Sharm el-Sheikh this November. All state-implemented projects like smart cities, roads, renewable energy, treatment plants, and national projects closely related to adaptation and dealing with climate change. I will start with a review of what happened in the Egyptian media regarding the mega projects. This, most of, Mr. Ashraf, most of the clips comes from Al-Ahram newspaper. This is the Prime Minister himself declaring the Egypt climate change strategy at the Nexus Water Food Energy Platform. This is the Minister of Environment, Dr. Yasmin, talking with her counterpart from Canada in Stockholm about the results of the Glasgow COP. This is the Ministry of Housing talking about challenges facing climate change and how to solve it using modern tools. This is the Minister of Electricity and Renewable Energy having some common projects with Australia in the area of green energy. This is Dr. El-Mashat herself, Minister of International Cooperation, with Mr. Tony Blair, talking about green projects. Even the Minister of Youth is talking about an initiative called Youth and Climate, how to deal with nature. In Egypt, there is an initiative of planting 100 million trees. and this is a Supreme Committee led by Prime Minister arranging for the COP27. This is the President himself talking to the Forum for International Cooperation, Development, Finance, telling the audience that we have a lot of potential to provide clean energy, and we have to support African countries. Now, I'm going to go through a hopefully pleasant tour through the mega projects in Egypt, and I will start with smart cities. A number of these, in Egypt, we introduced about 38 new smart cities, and some of these cities are near completion. We will mention only the new administrative capital in detail. These are the location of 20 of them, and you can see we have the new administrative capital in the desert here to the right, and then the new Alamein by the Mediterranean Sea. شباب it doesn't work. I should. Now, this is how the new administrative capital look like. It's a green city in the sense that for each person has 15 square meters of green area, and it is sustainable city in the sense that sustainability is considered in energy and in recycling of waste. It's a walkable city where people can walk or use bikes, and it is connected where we can use trains, metro, tram, trolley, buses, and taxis. This beautiful map I got from Dr. Ayman Ashur shows the relation of mode of transportation with the intensity of population in the residential areas. And it's a very nice slide that will be a transition from talking about smart cities to talk about Egypt transportation network. Without transportation, there is no development. And this fact is as old as 312 years before Christ, where Rome's most enduring contribution to history is the roads, a vast interconnected network spanning about 322,000 kilometers. This is an Egyptian map for transportation. We are connecting very remote places like Marsa Matruh, like Bursaid, places on the Red Sea, and even Aswan. And Egyptians, if you walk around, they use the metro and they use the microbus. But the microbus will not continue with us. Why? Because we are embarking on using 4 new modes of transportation: the monorail, the light rail transit LRT, the bus rapid transit BRT, and the high-speed train. This is the monorail, this is the LRT, this is the BRT, and this is the high-speed trains that can go as fast as 250 kilometers per hour. Now we move to largest agricultural wastewater treatment plant. This wastewater treatment plant is called Bahr al-Bakar, and it won 3 Guinness World Record certificates for being the largest capacity, for largest sludge treatment, and for the use of ozone for disinfection. This is where the plant is. The capacity of the plant is 5.4 million cubic meter per day, and it is used to irrigate about 400,000 agricultural land in Sinai. This is the Bahr al-Bakar drain. It is the longest and the most polluted in Egypt, but now, after the plant, we transform this disadvantage into a great opportunity for agricultural expansion. This is how the plant looks like. The other energy project is solar energy plant. not only the largest wastewater, we have the largest also solar power plant. It's in a place close as one called Binban, and it is supposed to produce an energy equivalent to about 90% of what is produced from hydropower from the High Aswan Dam. This is the location of the Binban, and this is how it looks like. Then we go to wind energy plants. I'm going to talk about Jabal al-Zayt, but recently Ras Gharib also won a prize for being the most recent plant, and we are supposed to generate 580 megawatts with a production of 2 megawatts per turbines, where the total number of turbines is 300. This is where it is located, along the Suez, Gulf of Suez, along the Red Sea, and this is the plant. Canal lining. This is Ministry of Water Resources and Irrigation. We are planning to line 20,000 kilometers of irrigation canals and to save 5 billion cubic meter annually that is lost through filtration and evaporation. Egypt has a very intricate irrigation and drainage network. And what you see here is the boundaries of the directorates. If you are interested, this is a big problem calculating the water balance for each governorate, because the boundaries of the irrigation and drainage directorates do not coincide with the administrative boundaries. And this is how a canal looks before and after lining. And because Egyptians are different, they added another recreational element to the canal lining canal by using it as a swimming pool. Now we go to rainfall harvesting, where we turn threats into opportunities by building obstruction dams to make use of the captured rainfall. Shore protection also, because we have around 3,200 kilometers of shores along the Mediterranean and the Red Sea. And this map shows how we classify risk on the northern coast. We have high risk, medium risk, and low risk. And this is a beautiful picture of Alexandria trying to protect the monument or the citadel by using hard structures. Here is an important thing in Egypt. We don't use hard structures, we use nature-based solutions. And these nature-based solutions are environment friendly, and it doesn't cost much. The most important that we use local experience to build such nature-based solutions. لو سمحت هنا يعني بالماوس بتاعك كده هتلاقي شغل الفيديو. Here is an interesting video, but because of this high technology, yes, I hope you can hear now.
One of the main breakthroughs over the past few years has been the realization that climate change, biodiversity loss, inequality, food insecurity were different dimensions of the same crisis. Here we are protecting the Nile Delta against the existing sea level rise. But with climate change, this phenomenon will continue. There are elements which are truly extraordinary in this project. The first thing is that we are speaking about ecosystem-based approaches. Rather than a concrete dam, we have basically used the power of nature to protect populations and natural resources. So it's much more cost-effective, but in addition, it's something that is living. An evolutive organic solution which is built on the knowledge of local population.
How many engineers in the world have the modesty and the empathy to be able to start by asking the local population, how will you do it? I'm full of admiration.
And actually, visiting this site has filled me with a sense of wonder. There is nothing that's replaced the opportunity to discuss with the ultimate beneficiaries directly. So it's a wonderful example in this project. We are leveraging the power of nature the knowledge we have acquired in terms of ecosystem management to avert catastrophic climate change.
I hope you like this. The last issue is green bonds. What is green bonds? Egypt is the first country in the Middle East and North Africa region to issue green sovereign bonds. This financing solution supports Egypt's Vision 2030, and it ensures access to clean drinking water and transportation through the use of monorail in Cairo. This beautiful map shows the locations of the many projects supported by the green bonds in the areas of desalination, clean transportation, water treatment plant, sludge treatment facility. For our German guests here, one of the first international bank that supports the green bonds is Deutsche Bank. This is my conclude. To conclude, Egypt is working on different initiatives to combat climate change, adverse effects at all levels, including ministries, academia, NGOs, and the society at large. Egypt's new republic is embarking on several mega projects like smart cities, transportation, treatment plants, renewable energy, canal lining, rainfall harvesting, and shore protection. And all these mega projects take climate change into consideration. Thank you. خلصت في الميعاد ولا ايه؟
Thank you, Dr. Ali. We have two questions. I'll read it loudly here. The first one, just a second. Dr. Bahrawi, what's in your opinion, according to your opinion, what's the role of academia within the climate change and the projects that you have been highlighting? This is the first question.
Yes, actually, what we are doing now is part of this academia role, but I think we are revising our curricula at the Faculty of Engineering, especially in our department. We work in water-related problems, and we are injecting a lot of elements in our curricula that introduces our students to the problems of climate change and how we face it in Egypt.
Another question from Professor Ahmed Abdel Hafiz. He's thanking you for the presentation, and he's asking, is there any certified reports for negative impacts of climate change on agricultural soil in Egypt?
Yeah, with agricultural soil, my knowledge is a bit limited. What I knew about negative effects of climate change is the production of agricultural land and the shoreline retreat. And of course, the heat the heat waves and some of the flash floods. But with respect to soil, you have to ask our great professor, Dr. Ayman Abu Hadid.
The last question that we have, you have highlighted several projects in different disciplines. Should we be, the question is more or less about, should we focus on one step more or another, or what should be the first step to move forward?
Our first step is in all these projects. All the people responsible for all these projects are taking steps. You can check the internet, or you can listen to the news. You will find that the whole country now is working on climate change. For the people who know about climate change, and possibly for people who don't know anything about climate change.
Thank you. Thank you very much. Thank you. Okay. Lots of papers and tools at the same time. Our second speaker is Professor Birgit Kleinschmidt. She's the Deputy Director, Institute of Landscape Architecture and Environmental Planning, co-speaker at the DFJ Research Training Group, Urban Water Interfaces, Chairman of Examination Board at the Technical University of Berlin. Dr. Kleinschmidt will be talking about monitoring and understanding ecological impacts of climate change from space. Dr. Kleinschmidt, please.
So, dear audience, also a very warm welcome from my side. I'm super excited to be invited here to the workshop. And yeah, it's really an honor to me to be here at the Einsheim's University. Yeah, it's high technology, but I'm from technical university and we are also struggling very often with exactly that problems or challenges. It was quite exciting for me to meet you yesterday, and we had intense discussion about some specific topics, and yeah, and they are nearly the same we have in Germany: droughts and heat events and flooding. So I'm really excited to discuss that after all our input presentations and the panel discussion and in the workshop. Perhaps we have a question to fill the gap for...
No, I mean, I thought that technical problems happens only for Egyptian speakers. It is universal.
So we tested that before, but oh. Yeah. But we are not in a rush, or aren't we? No. Or we change the order of the presentation? But give the team 1 minute, I think they will. So. Perfect, Inji. Thank you.
Maybe I can give you this. You can start the slides.
I have nice slides and images, so it would be nice to have them. So let's wait one minute. Yeah, Dr. Karim asked me to elaborate a little bit on our talks we yesterday had, and that was 3 different projects that we discussed. One was about urban greening, and that's also one topic I'm dealing with, and we are discussing how we can collaborate, because heat events in cities, and I think these nature-based solutions, and you have mentioned that before, that is really a benefit we should use in the future, not only in engineering. Well, now everybody is waked up. Yeah, that's it. Oh, so no, perhaps. Perfect. So, okay, don't lose more time. Again, warm welcome from my side. It's an honor for me to be here and to be invited to the COP27 workshop. Flooding is one of the most common natural hazard, with particularly disastrous impacts in low-income countries. And this study, published in Nature Communication, presents the global estimates of the number of people exposed to high flood risk in interaction with poverty. So, and it finds out that 1.8 billion people are directly exposed to extreme floods, and the majority of these people are located in South and East Asia. And you see that also the Nile data, in the Nile data, the Egypt population is heavily exposed to floods. So the most recent IPCC assessment report announced again Africa as a hotspot of climate change, and regarding to that IPCC report, it is projected that we have a positive mean temperature change. It is projected an increase in the number of days above 35 degrees. It is projected a mean annual rainfall change. The patterns will change. And it is projected a change in heavy precipitation, and it is projected a positive mean surface temperature change, both in the Mediterranean Sea and in the Red Sea. Yeah, but also Germany is heavily exposed to changes caused by climate change, and in this animation that gives you an impression about the drought stress within the last 12 months. And you see, starting in September last year, only in the northeast part of Germany we have these heavy drought events, but then normally in winter time the soil layer is re-wetted, but that didn't happen last year, so we end up this summer with an extreme and exceptional drought is really spread around whole country of Germany. And this drought stress and this corresponding increasing number of heat events has popped up, an increasing number of particularly severe fire events and extreme forest damage and loss of food production. So, but also a heavy number of rain and storm events took place, and you see the flooded metro station here, or the public transport has to be stopped due to wind throws. So to face the changes and its correspondence for our well-being and for a healthy planet, we need new technologies. And in the field of Earth observation, there are three main innovations that can be identified, which made Earth observation really to a leading technology related to climate change monitoring and development of climate change adaptation and mitigation strategies. The first innovation with the Earth observation policy and of manifold data providers, namely the Landsat mission or the Copernicus mission with the Sentinel fleet, they provide petabyte of Earth observation data recorded nearly in real time around the entire globe, and also tons of meteorological data and geodata are available. Because I have heard in Egypt it's not as easy to get these meteorological data for free of charge. In Germany we have this option, and it's absolutely great. So just to mention that you change your policy in that direction. So the second innovation is the in situ sensor technologies, which are available to calibrate and validate the Earth observation products to derive the information. Let me just mention here drone technology or cosmic ray Newton sensing for soil moisture content management. And the third innovation we have experienced in the field of Earth observation are new algorithms and models. For instance, machine learning have to be mentioned here, or the coupling, the smart coupling of different models like hydrological models and remote sensing based models. So I will present different scientific projects from my group where we applied Earth observation that are related to climate change, that improve the understanding of the ecological impact of climate change on the human environmental system. So heat Heat events are constantly increasing around the globe and expose the urban dwellers and lead to a higher mortality rate. So also in Berlin, we have exposed several heat events, and with the use of Landsat surface temperature day and night, we calculated or we examined the spaces where which are exposed to surface urban heat islands, and then we combined that information with census data, namely with age data, so infants and elderly people, the vulnerable groups, and so we came up with a risk map. So we can provide these to local authorities, and then they can plan mitigation and adaptation strategies with these risk maps. So, but for the assessment of urban human well-being, air temperature is more relevant than the land surface temperature that is provided by Sentinel. But the problem is that air temperature is only available by point measurements. So, therefore, we proposed an approach with machine learning algorithm to predict air temperature 1 day in advance. So, the innovative aspect was that we trained our machine learning model with crowdsourced real-time weather data from the world's largest community of smart home weather station that's called NetAtmo. And Berlin, we have around about 100 of these crowdsourced data sets, and I checked that for Cairo. A couple of these instruments have been installed so far. Perhaps in the future there are more, but they can be used. So, this project presented very clearly the potential of machine learning on the one hand and crowdsourced data to improve the modeling of relevant key parameters. So to face the impacts of human urban heat, local authorities need indices or simple tools to come up with smart mitigation and adaptation measures. So it is confirmed that the urban green infrastructure, and we have heard that before, is providing microclimatic regulation and thermal comfort through evapotranspiration on the one hand and shading on the other hand. So thus we proposed a method using open access data, again including hourly meteorological data, remote sensing data, data from related vegetation parameters to predict the heat fluxes using, in that case, a biophysical model. So, and the model has that model can provide then a so-called greening or greening cooling service indice, and that is divided into an evaporative cooling indices and a shadowing cooling indice. It's very simple. It's normalized to 0 and 1, this indice. And the potential of the model is that we can provide or calculate scenarios, different urban greening strategies, for instance, test them, or different climate scenarios. And then on an hourly basis and on a very high temporal and spatial resolution, we can provide this cooling indice. So, monitoring. As we have the chance with Earth observation to discover the past development, it is an intensively used method for manifold monitoring purposes, also in the context of climate change. So, and this example from an arid region in the Taklamakan Desert, that is in the northwest part of China, in the autonomous region Xinjiang, that shows time series analysis that can provide information to discover the degradation and recovery processes. And the floodplains in that areas have been massively affected within the last decades by intensive agricultural land use in the upper stream, and that led to water scarcity and loss of tree vitality in the lower reaches. So, to observe the degradation and recovery process, we applied a remote sensing change detection approach with breakpoint detection analysis And so we come up with it, or we could identify the positive, negative, and inverse trends that have been occurred in that region. And it's also provide that to the government and evaluate the ecological recovery measures from the government. So, and I think it's absolutely undenied that the climate crisis is one of the main drivers of biodiversity loss. So in this study, we developed a species distribution modeling approach to predict floristic richness and patterns of the threatened plant species under different climate scenarios. And the input parameters, very simple, from topography, soil climatology, and remote sensing. And we model for different RCP climate projections with the max-end model for more than 1,000 floristic species, the distribution. And with the aggregation of these, we could found diversity hotspots and hubs of threatened species and could propose conservation importance units to contribute again to nature conservation management. Here in that case, that's an example from Brazil. So let me move to the topic new innovative in situ data collection. And again, soil moisture is really absolutely challenging parameter in the global, but it is relevant in the global water cycle, and also the same key, also a key parameter for farmers, for instance, for irrigation planning. But to derive soil moisture, it's at the regional scale, it's still a challenge with remote sensing systems. So far, we need reference measurements, and they are normally collected plot-based. So in this project, we tested with an interdisciplinary group of potential soil, disciplinary group, the potential soil moisture modeling with cosmic ray sensing instrument. You see that on the right side. And we combine that with active and passive satellite data system to estimate soil moisture content. And the novelty of this instrument is that it covers more than 1 hectare by measuring the soil moisture, and also 80 centimeter depths. And with that, we filled the gap, the scale gap, to the usually point measurement and improve high temporal and spatial soil moisture modeling. It's basic research, but the next step is really to bring this model to a catchment scale. So then last example for new technologies, drones. Another example for bridging this gap between terrestrial measurements and the view from space. And we used drone data in our project very often to discover a few hectares in combination with terrestrial measurements for biophysical parameters like LAI or leaf water content or soil properties. And on the slide, you can see the UAV-based multispectral point and LiDAR cloud recorded in Siberia for post-fire succession monitoring. And with a combination of the optical and LiDAR data set, 3D vegetation model can be calculated, and from that, forest structure parameters can be derived. So let me finally draw some conclusions. Yeah, a very general but big challenge is to move from a climate risk to a climate resilient development. And in all our research and efforts to adapt and mitigate climate change, we really need to consider that climate and ecosystems and human society are coupled. That's absolutely essential. Then, secondly, Earth observation with all its components and facets can make a particularly important contribution to a better understanding of the human environmental system and its response to climate change. So the quality of remote sensing derived information can be improved by combining different types of data and different scales. And that means we have now really the chance of mining the potential of different sources of geodata and new technologies. And finally, to discover drivers, pressures, state and impacts of and the response of human environmental system caused by climate change, inter and transdisciplinary research is absolutely essential. And let me end up with the presentation with a statement of Huasong Li, the chair of the IPCC. And he stated, "Our actions today will shape how people adapt and nature responds in increasing climate change." Thank you very much for your attention.
Thank you, Dr. Birgit, for being on time and for this nice presentation and all the pictures you have shown us. We have a couple of questions. The first one regarding the accuracy of the meteorological data and as a monitoring tool to predict the negative impacts of climate change, either on the short or long-term periods.
Yeah, I'm not the meteorological expert here. I can elaborate a little bit on this crowdsourced data, and these data are not as reliable as the data we are provided by the German Weather Service. So we have to, this uncertainty has to be considered in the models. But I think the data from the Meteorological Weather Station, I think these two colleagues are the experts in that field and could perhaps later or now answer that question.
Good. The second one is, where do you find the common challenges and how can academia and this form of cooperation between universities support that and solve the challenges that you mainly face?
Yeah, I think listen to the experts. So I think we are doing great work and find out very interesting aspects. But we have to bring that from academia to the political state, and so it was so important to have this discussion with the representatives from politics, and then I think jointly we can really push toward a climate resilient world.
Thank you very much, and we will resume during the panel discussion further questions. And
okay. Thank you very much.
Would you please give us a round of applause? Our third speaker now is Professor Jörg Bendix, head of the Laboratory for Climatology and Remote Sensing, chair of the Geoecology University of Marburg. I'll just read a couple of lines further from his bio. He's heading the Laboratory of Climatology and Remote Sensing. Since 2011, he has been elected as member of the Academy of Sciences and Literature in Mainz and the National Academy for Science, where he was part of the working group recently publishing the report on tomorrow's science, Earth system science, discovery, diagnosis, and solutions in times of global change. And he will be talking about, Professor Jörg, about remote and proximate sensing options to better understand climate change and impacts on ecosystems. So, yeah.
Maybe I can use this mic.
Sure.
And I can show. Yeah, that's working.
But you need to point to show on this pointer while.
Oh, really?
If you want to point on something, it's on this one.
Yeah, but the pointer's not working, so I can show it on the screen. Yeah, for me also good afternoon. So it's a great pleasure, and we're waiting for the techniques to be here. So I've never been in Egypt, and I was very much impressed about the discussions in front of this meeting. So what has been done here, which interest is here, and I'm very much looking forward about this event today. Yeah, and, so in the next 15 minutes, I try to inform you a little bit about this very complex title, proximate remote sensing, and so on. But our main focus is on the atmospheric water cycle, and that's why I would like to focus on that. So if we are starting with the atmospheric water cycle and what we can expect if we are not coming to action is that we have three main parts which are interesting. That is water vapor, that is clouds, which can condense from water vapor, and that's, of course, rainfall if the droplets are growing, and that feeds back, of course, to the water vapor via the interaction with the ecosystem and mainly the evapotranspiration. And that's what we have to know. And if we are looking into future, then you can see we are expecting more precipitable water in the atmosphere, because it's getting warmer, evapotranspiration is globally increasing, but at the same time, because the saturation is temperature driven, so we get to a reduction per Kelvin warming of the relative humidity in the air. And that means that we expect less cloud, less rain, but because we have a lot of water, if dynamically rain is generated, then it comes to heavy rain. So that is a very interesting thing we can learn. If we are looking into clouds, clouds are very important. We are very much interested in low stratus clouds in our research because globally clouds have a cooling effect. They can mitigate climate change. But if they are disappearing, then we are running into problems. And if you are looking at these regional projections of the IPCC, you see regionally we have a very strong decrease, unfortunately, mainly threatened the Mediterranean and Northern Africa. So we get less clouds, and globally maybe we come to a loss of the cooling effect of the clouds. And last but not least, of course, if we are looking into rainfall, so then we can see here in the maps the consequences, and we have already heard it in Birgit's talk, is that we come to more agricultural and also ecological droughts with all these negative consequences for vegetation, rain-fed agriculture. We need more irrigation in dry areas like Egypt, and what is going on with heavy rains. So we have some ideas, but we will hear in the next talk, I guess, much more about this topic. So I just would like to browse now through the three parts, because we have to monitor this, as Birgit already said, and we can monitor all these parts of the atmospheric water cycle and the impact on ecosystems with remote sensing technology. And that's what we are doing in Marburg. And maybe I start with a completely other country, because we are very much working in Latin America and the high Andes, in a country where we don't have meteorological information. And so what we did and tried, because this is also a country which is affected by a lot of heavy rain sometimes due to the El Nino phenomenon, is in a transdisciplinary project with stakeholders, with Ecuadorian and even now Peruvian universities, to set up a X-band rain radar network, which gives us spatial explicit data in 500 meters and 5-minute resolution. And that is very interesting, because here you can compare some information you can get from rainfall measurements. So that is a gauge network, which is very scarce, so you can interpolate it, but the results are not very good. Here is a broad-scale satellite product, GPM iMerge, that's the gold standard at the moment. And yet then you can see, if you have gathered a time series, that you really get detailed information in space and time, and you can use it. Here you see that is one of the biggest El Nino in the last parts, El Nino 2050. You see a lot of inundations and flooding in an area where there's almost no meteorological station. So you can use these technology as well for nowcasting extremes, which might be increased during climate change. But of course, if we are thinking about Egypt and the Nile Delta, that's far bigger than Egypt, and you can't equip it with X-band radar technology. I guess it's more or less impossible. So you must rely on satellite products like the Global Precipitation Mission of NASA. That is a spaceborne rain radar, but unfortunately, that has no full coverage. So there are gaps in time and space of these retrievals. And what we are doing now is, in our research, to using the geostationary satellites with high resolution, 15 minutes, 3 kilometers, which is also covering Egypt, of course, to calculate with machine learning technology rain fields, which we can then produce rain maps and of course also can monitoring rain. Here the example for Iran. And this can be also used to fill the gaps which are in this product, GPMI merge, that's the gold standard. And I cannot go into detail here, but you can see if you are using multispectral satellite data, implement in this iMerge product, you can really much improve the quality of rain area retrieval and and rain rate retrievals. So let me come to the second example, clouds. I also cannot go into detail, but we are very much into analyzing longer time series again of meteosat second generation with regard to low stratus clouds and ground fog. So we have also implemented a machine learning approach, which is a little bit hybrid because it uses physical-based thresholds and then machine learning for retrieving the cloud base, which is very important if the cloud is touching the ground or not. And with this, of course, we can then produce also maps on the first one hand, that is low stratus frequency, that is ground fog frequency, they are a little bit inverted. And to having time series, which is very good, you can also see that we're 10 years of MSG data to think about if it's decreasing or not. That was the main topic. And you can see here, particularly in wintertime, the blue colors means that we have a very strong decrease in Central Europe with regard to low stratus and fog, which is this cloud type, which is very important for the cooling effect. And now comes the impact to the ecosystems, because we, of course, would like to understand how this atmospheric moisture works with ecosystems. And I have brought you an example from dry areas, from the Atacama, the driest desert of the world. And what we have found here are these tiny organisms, biological soil crusts. And so now you need, of course, because that's another scale, you need proximate sensing, like hyperspectral monitoring, and to convert this hyperspectral data by some procedures to net photosynthesis. And what we have learned in the field is that these tiny organisms are very much reacting on fog water deposition, because there's also a lot of fog. They are very much adapted, and these tiny organisms are very important if you know where they are, because they can stabilize the soil against splash erosion or dune movement or whatsoever. And they have a lot of effect on carbon sequestration. That is their function, which is where you don't have other carbon sequestration in dry areas. So, as Birgit said, we need a cross-scale monitoring to link these very tiny organisms with a larger area to learn about where they exist. And you can see we are combining drone-based measurements, profiling of the clouds, or here a high-resolution mapping of the drones in several areas. Then we need some time series to learn about fog occurrence and fog water occurrence, which we could retrieve from Landsat. We need some measurements, of course, and all these in combination with the machine learning algorithm shows you that we have here really a high coverage of these tiny organisms, so they are relevant. That is very important. Last point, and then I come to the end of my talk, is the water vapor and the interaction with the vegetation. And what you can see here is, again, Ecuador. That is work from the high Andes, from Grass Paramo, where we tried out in a very good gorged catchment area energy balance model, which is retrieving evapotranspiration in different scales, and to compare it with global products. And what you can see here, that is the water balance, that the high resolution is very close to what we really get from the water balance of the catchment, and the global product, MOD 16, is the worst. So it's not representing really the evapotranspiration in this area. My last slide, now we have to come into biodiversity, because below the Paramo we have this mountain-rich eastern mountain rainforest, and there is some threat with the entire Amazon that it's get drier. And we were interested what is happening if we are comparing dry and moist phases in this mountain rainforest, which are also increasing, particularly the dry areas. And here we need higher resolution satellite data because we want to come to this single tree entity. And what we could learn, that is again another methodology calibrated with scintillometer data. In the fetch area of the scintillometer, that we found trees which have two different strategies. One of the trees are evaporating more if it's drier, others less if it's drier. And you can imagine what happens if we have more droughts. The one will beat the other one. So biodiversity will get a shift, and that is very interesting. So that's my very brief overview, what we are doing to relating or to monitoring the atmospheric water cycles and the impact to the ecosystem with remote sensing. We have already seen, so there are a lot of products on the market where you can do monitoring in times of global change together with machine learning. That is a big tool. If you are using standard products, you must be very careful because they must be normally calibrated, which means you need measurement data in your country. So you can't rely on these global products. That's absolutely important. And the next one, long time series, are important. So to learn something about the changes, that's not too long at the moment in the satellite domain, but we are getting new satellites like Meteosat third generation is now heading to be launched. We have the new hyperspectral satellite NMAP. A lot of good data, and I hope I could show you scale matters. If you really would learn how ecosystems or tiny organisms are reacting, then you need this scale-up monitoring system, which is bridging from proximate sensor over drone to the satellite level. Yeah, and now I'm looking much forward to the working group meetings to learn what is needed or what is already done in Egypt. Thank you very much.
Thank you very much, Dr. Jörg. We have a couple of questions. The first one, it's more or less about the applicability of these technologies. You have highlighted that you have used these technologies in Latin America, and you talked about the local data. But aside of that, what are the challenges of applying such technologies in maybe least developing countries?
So the biggest challenge is sustainability, I would say, because I say not easily, but you can implement the technology, you find the money, but then you need long time series. And mostly, you know, the funding is restricted, temporarily restricted, and after 4 or 5 years, the stakeholder has completely to take over the system. And then it must be maintained and something happens, and that is, I guess, the most complicated thing in such networks if you are not able to warrant sustainability, to find an agency which is really doing that, and it's not the weather service in Ecuador, unfortunately, then you are running into problem on the long term.
Okay. Another question, you gave as well the model of the Amazonia, and the question is more or less about the monitoring biodiversity elements in protected areas, like here in Egypt, for example. To which extent this is doable or possible?
Yeah, I guess there are a lot of also examples. We did it as well, so to calculate multifunctionality for different species groups from remote sensing, that is possible, and normally you are really using also, of course, ground data, which you need on biodiversity or functional diversity, what you ever would like to analyze, and then you can, of course, use machine learning to link this. That is possible to a certain extent. We already did it in this biodiversity hotspot with insects and so on, and also some plant groups. And then, of course, you have to come to monitoring. That is complicated because you have to apply these models, and from time to time, because it's not very simple how these interactions between the organisms, and you have to recalibrate it definitely. So without ground-based analysis of biodiversity, I would also say, take care.
Yeah. The last question, the impact, it's about what's the impact of floods on the soil quality on the medium and long term, and if this could be monitored in a way or another.
Yeah, so that was what I've learned in this Atacama Desert, because that's a completely, for our eyes, a completely unprotected soil. And there are some floodings, which are strong rains, which are also increasing now with climate change. And so there was a really huge landslide which covered completely the city of Chañaral with a precipitation of only 50 millimeters per day. But in a desert, that has dramatic hazardous effects. So, and that's why it's very important to work with the soil crusts, because these soil crusts that has shown our analysis has really much helped to save the ground a little bit against this splash erosion.
Thank you very much, Professor Jörg. Our next speaker is Professor Ayman Farid Abu Hadid, former Minister of Agriculture and Professor Emeritus. Professor Ayman will be talking about vulnerability and adaptation of the Egyptian agriculture to climate change.
وده ايه؟ ده next. Okay. تمام. أكلم من هنا. Thank you very much. It's a pleasure being with you today, talking about the vulnerability and adaptation of Egyptian agriculture to climate change. Actually, the story of the agriculture in Egypt is quite long, starting 30,000 years ago, when Egypt, south of Egypt, was in the savanna of Africa, and that the Stone Age people used to live on hunting of animals until they started domesticating the animals in the range of 10,000 years ago, and start also to domesticate crops like olives, barley, wheat, and so on, in the same range in the Fertile Crescent in the areas from the Nile Valley to Near East, and then Euphrates and Tigris. And 4,000 years ago, the Nile was domesticated, and it was also introducing water to quite a diverse of crop. And some tools were innovated in this time, and I think that some of them are still in use now, as you can see in the middle photo. Also, several farming systems were developed and increasing the productivity and so on. What happened after that is the accelerated climate change issue. It is the climate change is a fact that we have already 3 ice ages in the past, and the acceleration of the cycle in the middle of the last century actually was raising a flag. And we have to learn from the history that the carrying capacity of any particular area is very important. In the past, we used to advise the grower how much water to irrigate, and the grower used also to learn himself about that. But now, I think the changes are very rapid, and we have to depend more and more on science and technology for the agriculture sector in general, and in particular on water. There will be a problem related to high level of water that will affect a large area of the Nile Delta, and if not submerged underwater, it will be actually salinized by the introduction of the salt water to the soil. And also, the second point, which is very important, is the temperature. Temperature increases, and the range of increase may prohibit growing specific crops, and we have to look continuously on the tolerant crops that can survive under such an increased temperature. So we have to look at two directions. One of them is breeding crops to tolerate salinity, to tolerate lack of water, to tolerate high temperature. And this is a continuous process that we have to go. The major threat for the region will be the water scarcity. And the water scarcity will hit the Middle East region and North Africa, and Egypt will be part of this region. But also the extreme weather events will affect agriculture. Storms, floods, extended droughts, and so on. It will be also a major threat for agriculture. And this will depend on three elements: the nature of and severity of the event, the vulnerability of the system, and the exposure to the element. And this actually what we have to consider planning for resilience. The challenge in Egypt, as far as we recognized, is listed in this slide. We have to cope with water scarcity. We have to look at the possibility of overcoming the desertification processes and the salinization of the soil in several areas of the delta. We have also to look at the constraints related to food production, because if we don't produce our food, we have to buy it from elsewhere, and there is several theories that we might be not able to found this food in the international market. This is a very serious point. Also, water governance. We have to look at the water governance and how can we distribute our water appropriately and justice. Also, we have to reorganize our organization and institutions and eliminate the duplication. For example, between the Ministry of Irrigation and the Ministry of Agriculture, and who is who. Dr. Ali al-Bahrawi have mentioned a very good presentation on canal lining, including a statement that I may differ with, which is that the canal lining will save 5 billion cubic meter of water. And I have another point from Dr. Hussein al-Atfi, who was the Minister of Water, yes, and he said that lining will not save water, but it will improve the environment. So we have to be very...
So dear audience, also a very warm welcome from my side. I'm super excited to be invited here to the workshop. And yeah, it's really an honor to me to be here at the
our rule and acts of agriculture dated back to 1954 with several changes and other decisions that altered it. For example, we have a decision about, or an act about the planning for agriculture and the distribution of crops, الدورة الزراعية, distribution of crops over the country. This was by law, but in the same time, in 1995, a ministerial decree discarded this law. So we have to look at the possibility of improving our legislation and so on. Major point is the data and the information availability. Without this, we cannot actually proceed for the future. Our situation is very rough because if we compare the annual renewable water share, our situation is very rough because if we compare the annual renewable water share, our situation is very rough because if we compare the it is 8,500 cubic meters annual renewable water share. Our situation is very rough because if we compare the renewable water share, our situation is very rough because if we compare the renewable water share, our situation in the middle of a region where we have acute shortage of water, and this shortage of water will affect different crops. Crops will be affected by temperature in general, and we will have reduction in productivity of almost all the crops, ranging between 11% to 55%. And this is a very serious reduction in productivity. And also, due to the increased temperature, there will be an increase in water requirements for these crops. The increase will be 2% to 16%, but for all the crops there will be increasing water demand. Increasing water demand, and in the same time there are additional insects and diseases that will come. We have to look at our system of irrigation, the surface irrigation system in the Nile Valley and Delta. We have to keep our agricultural land without urbanizing it by building over it, while the desert is just a few kilometers away. We have to look to save this for agriculture. And in the same time, knowing that some areas, the dry areas will be drier, and the wet areas might be wetter. And in Egypt, we have the dry areas like the northwest coast and the North Sinai, that will be drier. But in the same time, the Nile might have additional water for precipitation, so we have to look at the situation equally. Also, the extreme weather events affect the country and affect also agriculture, especially on the coastal area. If the seawater level increase, that will submerge some parts of the delta and will salinize other parts. Some areas will disappear underwater, and we have to look at the possibility of protecting this soil from the seawater level rise. In the red areas here, we can see this is engineering protection available. In the blue line, it is unprotected area, and very serious saltwater intrusion can happen from this area. The green line is natural protection, either by sandy dunes or by elevation of the area. So we have to look at this. Also, we are blessed with the presence of several new tools of science that can help us to adapt to climate change, including the remote sensing, the biotechnologies, simulation modeling, and this can help shifting our system from the primitive agriculture to the modern agriculture to increase productivity. One of the tools also is protected agriculture or greenhouses. And we have to look at the greenhouses for improving the productivity and saving water. For example, if we grow animal feed in the open field, the acre will consume 12,000 cubic meter of water a year. But if we have this sprouting technique in greenhouses, attach it to the animal farms, that will reduce the amount of water to at least 1/4 of the amount of water used for growing the fodder in the open field. This is one thing. The other thing is hydroponics to grow vegetables. We grow tomato, for example, in 450,000 acres a year. And the cubic meter of water produce 5 kilograms of tomato in the open field. If we use it in hydroponics, in greenhouses, the cubic meter of water will produce 54 kilogram of tomato. That means our need of tomato, we can make it sufficient from only 50,000 greenhouse acres. And we can save the 400,000 acre for other crop in the future. That is very important issue. Also, when we talk about land reclamation, we have to have agro-industrial complexes that have 4 companies actually working on the same area. One for plant production, to grow seed, grains, sugar, and so on. The second is to manufacture this product and value add to it and make it available for shipping directly to the market instead of shipping the raw crops. From the 2 operations, we will have residues that is not in use. Then we can use it for making feed for animal. And to feed the 3rd project with animal production. And the animal production will also have residue, which is the manure that can help in fertilizing the first project. And the 4th project will be slaughterhouse and the factory for preparing leather, for example. So we have to have this kind of integrated approach in order to best utilize our natural resources. The second natural resource that we have to utilize is the gradual changes of climate from the Mediterranean to Aswan. In the Mediterranean coast, we are in the moderate, nice, warm winter climate. And in Aswan, we are in the Sahel and Sahara climate. So we have to have a very detailed study about the agroecological zones in the country. And we have to study also in each zone, what crop can we grow and what is the resources needed for this crop, and to be restricted to the plant of the agricultural distribution, crop distribution over the area. My last point about the water utilization. Here we have in the beginning of the 20th century, the share of per capita for Egypt was 5,000 cubic meter per year per person. Now it is 500 cubic meter per year due to the increase of population. We have to look at the possibility of solving this problem, and the only solve for the problem is to reduce the increase of population, because otherwise we will overscale our carrying capacity in the country, and we cannot save it this way. The Nile system depends on the main canal of Nile, the main branches, which is actually the secondary branch. These are 3 levels that have to be organized by the Ministry of Water. resources. Other than that, the third and the fourth level, which is the MESCA and the MERWA, have to be organized by the Ministry of Agriculture because it is within the agricultural land. And it is very strange that we see that the Ministry of Irrigation is still looking at controlling this level, and even with the need to biology and crop management, we have to forget about the surface irrigation system. We have to go for a better, there is no way other than that. We have to go to the better irrigation system. Imagine how much how much water is driven from here and how much fuel is used for lifting this water. And also the waste of evaporation here in the canals. We have to look at the possibility of changing this to the new modern systems of irrigation. And this will increase the water use efficiency from 45% in the surface irrigation system to 80% or more in the modern system. And that will save 35% of water that is used now and wasted due to the system. And also there will be, it is very important to improve this system, and also it will save the health of the farmer due to neglecting the waterborne diseases. This will require additional information and additional technologies related to how to control, how to estimate the exact amount of water required for each crop, for each region, for each season, and have it on maps and have it on mobile applications to advise the grower according to what we can see. Thank you very much.
Thank you, Professor Ayman. Just before starting the questions, I have noticed in one of the graphs that you have shown regarding the reduction in crops production, there was just one crop, the cotton, if I'm not mistaken.
The cotton, yes.
Why did it increase compared to the other ones?
The cotton actually is not proceeding to fruit development, and it depends only on the biomass. So that's why it will increase in productivity. And the increase in temperature will promote the growth of cotton, and will not affect it badly as the other crops.
So that's a good impact of climate change
Yeah.
on crop production. Okay, we have a list of questions. I'll start maybe with the last one. Would you think that microbial biotech solutions will help improve the fertility of soil salinized due to the seawater intrusion in the Nile Delta?
Several things, including this, yes. I think it is. It can be useful to increase the ability of the soil to produce under stress.
Okay. Another question, how do you see the current rate of urbanization as a climate threat, especially after the reduction of urban green spaces? And how can this be reduced or stopped in a way or another?
I think that the most important thing is to forbid the building on the agricultural land. And also to stretch roads from the agricultural land that have dense population to the desert, to the nearest area of the desert, and have parallel villages or something like that to improve that.
We would like to welcome Dr. Mahmoud Al-Mitani, President of Ain Shams University.
خسارة يا فندم كنت حضرتك حضرت معانا.
تمام. Our last question about the desalination strategies and which one of these strategies are a better solution for quick action, underground water desalination or seawater desalination?
I think that the most important thing is the seawater desalination, because the underground water desalination may affect the content of the soil to water and may introduce more soil, salty water from the close by sea to the soil, and therefore make it worse in the future.
Okay. Finally, we have a comment by Professor Ahmed Abdel Hafiz. Adaptation strategy through breeding tolerant varieties might not serve well in the future with the continuous rising of temperature. So, do you have a comment on this one?
It is a very long story, and I think that we can discuss it later on, because it also requires some specialized persons.
Okay.
Yeah.
Thank you, Professor Ayman. Thank you. Okay. Hi. Dr. Mahmoud, would you like to give a welcoming word?
بسم الله الرحمن الرحيم. كل سنة وانتم طيبين عشان 6 أكتوبر. Let me first of all welcome the German delegation and apologize for being late. It's really out of my hand, because today was a presidential obligation. You know, the 6th of October war, we always celebrate at this time of the year. And because it's actually the 6th of October will be on Thursday, so it's a vacation. So usually the president make today the celebration. So we have to be there. So I'm very sorry, and I'm sure that, I don't know, I can see Ayman and our colleagues, they were here. ها ان شاء الله يبقى اجازه برضه هنحتفل بيه. كل سنه وانتم طيبين جميعا بمناسبه المولد. يعني السنه دي الاثنين جايين مع بعض، فحاجه جميله واجازه كويسه، خميس وجمعه وسبت. So I had the pleasure and honor to meet yesterday the Vice Minister in the embassy. I don't know if he's here or he left. He left, okay. And of course, working in Shams University with 3 distinguished, very reputable German universities, it's a pleasure and an honor for us. I met before the Marburg delegation with our faculty of antiquity. And the TU Berlin, I used to be with them in Elgona. I don't know if they are still there or not. Yeah, still there? No? Seems not. No, because Samih is a close friend, and he told me that he gave up. Huh? Yeah, I know, because I was a member of the board for a while, and I don't know where you moved to, but maybe to Ain Shams soon, or... and Freie University, Berlin as well. So I hope that you had very fruitful meetings today. And I'll be very happy to receive you in my office when you finish, to wrap up and to see what we can do in the future at different. Of course, speaking about COP27 that the whole world is waiting for in next month. A lot of events and lot of initiatives have been taken by Ain Shams University over I would say not only the last year. I think we started early on in 2019, 2018 even, very good steps at both levels, whether at the campus level and the Shams Be Green, the initiative of the Faculty for Environmental Studies, that we're trying to implement it and to make it really a real life and a day-to-day experience for our students, our administrative body, our faculty and everything, and our role within what's going on in the country for the really change to green, to better environmental situation at all levels, water level, recycling, renewable energy. And I think our faculties and our colleges are taking very good initiative and very good steps, and research as well, research output was very good over the past period from NCHAMS and from our peers from our Egyptian universities. There is a small booklet that I asked you to prepare it. I don't know if I saw it yesterday. I hope it's finished, but we didn't have the time to print it. But maybe you can share it with your German colleagues. It wraps up, it wraps up all what you've done. And of course, you're sharing what they are doing, which is, I'm sure that it's several things. This session is minded by the precision agriculture or water or what? There are how many sessions today you're having? Three. And this is first session. Okay. So I just missed the opening ceremony. Yeah, about the water. Yeah. Okay. I'm sure it was very good and very interesting. Maybe you can share it with me later. Okay. Have a great day, and thank you very much for coming, and thank you for my colleagues in NCHAMS University for making the effort to make it a success. And I would like to meet you at the end of the day and see what we can do together. Thank you.
Thank you, Professor Matini. Now I'd like to invite Professor Uwe Ulbrich, Dean of Geosciences Faculty, Vice Executive Director of the Institute of Meteorology, Head of the AG Climate Diagnostics and Meteorological Extreme Events of Freie University of Berlin. Professor Uwe will be talking about weather and climate forecasts, scenarios, and extreme weather impacts.
Thank you very much for the nice introduction, and I'm very proud to be here, to have the opportunity to get to learn more of you, because it's my first time in Egypt and the first time in Cairo, and of course at the first time at the Ain Shams University, and it is a particular honor to have the president here. So what I'm intending to talk about is a little bit on what was mentioned previously, that is more on methods, on ideas, how to address properly climate change problems. And I'm trying first to show you that it is not just Egypt, but we have had quite a number of such events in the past, where always the question comes out, is this related to climate change? Is it something that we have had before? And we have had all kinds of such extremes with adverse effects. And indeed, it is also the drought problem that came up in the recent year in Germany, and forest fires that really changed minds, in my opinion, in politics, but also in the people's minds. And when I talk about extreme events, I have always the view of their effects, because these extreme events affect different regions, different parts of society, population, infrastructure, which, whoops, that goes quick, roads, rail traffic, supply chain, agriculture was just mentioned in the previous talks. And how do we address these extreme events properly? What can we do? Well, we have first to think about what is the background of their strength. And the backgrounds include the hazard intensity. Of course, if it rains very heavily, the degree of this is moving and keeps moving, I go always quick back. The hazard intensity is, of course, clear that it is important, but it can also be the hazard duration, which is as important and must be taken into account. As it was mentioned previously, of course, vulnerability is a key to the impacts, and these entities are influenced or may be influenced by prevailing climate, for example, a basis, for example, that a drought period can be much more dangerous if there was a previous drought or little rainfall. And so you have to take these changes of vulnerability into account. How to address these challenges, in particular related to climate change? Well, I think the first and most important part that has nothing or little to do with my scientific expertise is that you need to have impact data that are collected. Usually this is not the task of scientists, it is the task of agencies, of state agencies that must make sure that these archived impact data are not only there, but they are made available for scientific addressing them and for understanding what hazards, what degree of hazard, like I mentioned before, intensity or duration, these things, how they are related to the impacts. You need, of course, observational data, and I learned this is a problem, in particular in Egypt as well. I've known this before, where I've worked on the Mediterranean, and we produced maps, and for North Africa, there was always too little data to have really reliable results, and this is something that I think should be, if any possible, changed, and that you really, from the scientific side, address those responsible, that they change the politics. We did have that in Germany 20 years ago. It was really difficult to get, for example, meteorological data, and this has changed completely in the meantime. So they are freely available, and this fosters the scientific approaches that we can do from science and helping then to make the right decisions. Of course, you have uncertainties, and you have to address uncertainties that include greenhouse gases, the future climate developments model that we are using, and I'm going to show you a little bit. They may have deficits. You have to take those into account. And so what I show you first briefly, you all know that is that we don't know for sure if the 1.5 degree goal can be achieved. And I'm going to show you that this should not stop us from making scientific approaches to that. This is the reason why not. This is a number, just an example for Germany, number of summer days and annual precipitation produced by individual models under assumptions of, say, green of a RCP 2.6 scenario and a high RCP 8.5 scenario, just for comparison. And in the top figure, you see the number of summer days, and the blue one is the weaker scenario, and you see they increase to a different degree. But what you also see is the individual model runs. And this clearly shows that no matter what happens in terms of climate change, you must be prepared that there could be heavy events even in a low scenario. And I'll show you this. The bottom one is for annual precipitation for Germany. You do not see much of a signal there, not much of a difference in the annual precipitation. But what you see here is the change of sub-daily, that's 3 hourly in this case, rainfall events that have a 10-year return period. It's just as an indication for really heavy rainfall events. And what you see on the left figure is a near period under a moderate climate scenario, and what happens to the end of the century. And the browner it is, the greater the factor, the increase in the number of such events is. And this is the moderate scenario, close to present day and further away. And what you see in the next one is the intense climate change scenario, and you see, well, in the first place, in the near future, there is not so much of a difference. But in the far future, there is an enormous difference, and so we need to take care that we are going on the right path. But for the near future, we have to take care anyway. How the likelihoods are that extreme events are going to happen. And this just shows you an additional thing that we can draw out of the models that we are using in meteorology and climatology. That is the question in how far these things happen at a specific time of the year. Because you have to know, of course, when these things happen, because the agricultural cycle has to be taken into account. This is one thing. And what you see here, that is just from a small number of relatively small number of models. And when you look at this Central Europe picture at the lower right, you see that here the change from the present day, the gray bars, to the climate scenario, the weak one, that's the light brown, and the heavy one. This is the major change from present day to any of these scenarios. And the difference between the large ones in this particular case, according to these models, of course, is not as large. When I speak of heavy rain as an example that I took out, because we are currently doing research in several projects on that. One approach is that we need to have probabilities for local extremes. How do you get them out of models that are large scale or global? Well, you cannot. You can do downscaling efforts, and you can do downscaling efforts to even a kilometer scale, for example. And doing that is not that you believe into one single model run, but you need to have an ensemble of these runs for the same situation to have a proper estimate of what can happen with what likelihood. And this is an approach, I think, that is quite important to take into account once you have such data available that come out of the meteorological models that are available and that we are doing. And the last thing that I wanted to point you at is that climate change is something that you always see as something going up like this. Oh, the lower right figure shows you these examples. But this is not the whole truth. As you see in the lower left figure, there is variations. There is decadal, multi-decadal variability. And so it can happen that things are delayed out of this long-term development, and people think we are safe. Nothing is happening, they are all wrong. And it can be the other way around. They say, oh, what a problem, and it will become even worse. And this is still part of the decadal variability. It just goes up earlier than you would expect from a slow-moving process. And what you do is ensemble forecasts with global models that start from a specific, in particular, ocean situation to try to estimate the near future in the next couple of years, which can be quite useful. And this is not just being done in Germany, it is also done around the world. And the World Organization for Meteorology has collected these results and shown ensemble results in how far in the next few years there could be a larger rise in temperature or in precipitation according to these models. Of course, you have to address this in a probabilistic way. And here I come to my summary. We are looking at hazards. It's one thing, and I think it is important. But in the first place, we need to understand these hazards in order to address them properly. And we need the, whoops, not yet. We need to have the understanding from data. And the data must include data on the hazards, but also on the measurements about the environment. They must be there and they must be available. Second thing is, there is not one truth. You need to address, and we all need to address, these changes in a probabilistic way using probabilities. And it was mentioned before that it is nice that from the natural science side we get some ideas, but this doesn't help in the end. You need to work together with other scientific disciplines and address the linkages, both with respect to data, but also with respect to understanding each other. And not forgetting the stakeholders. The stakeholders are key, and this was again mentioned before. You need the stakeholders to have a sustainability. It's wonderful if you have a scientific paper, but in this context, it is needed that there is a sustainable addressing of climate change problems and implementing of things that you and we as scientists have found out and doing proper, suggesting at least proper approaches. And as I said, natural scientists, of course, social sciences should not be forgotten, because if you do not get the people and their ideas properly, in not taking them into account, you will in the end fail anyway, even if you have the best ideas. And now he comes to this picture. Thank you.
Thank you, Professor Uwe, for the interesting talk and even the slides that you have shown. Before going to the questions, I've just noticed that you had two slides, one with the moderate scenario and the other one with the extreme ones. Which one do you show to the policymakers and decision makers when you're giving your talks about?
I like to show both.
Okay.
Because they should see what I said. There's a short-term development, and no matter what, you have to take care of that anyway. And if you have the strictest measures right now, there is still ongoing climate change. It doesn't help. You have to adapt. But for the future, you have to do the changes of greenhouse gas emissions, and you have to do them now and not in the future.
Okay. And the second question, and this we have discussed it a few minutes ago, is the 1.5 limit that was based on Paris Agreement. Is this still doable, or we have already passed it, based on your data that you have seen and monitored?
I would say, yeah, it is still doable. But if you ask me for the likelihood it's going to happen, I don't think so. 2 degrees is a challenge enough. And we should have we should make sure that we are not exceeding the 2 degrees.
Okay. Okay. So now with the questions, most of the climatic data are interpolated data. Then how to account for uncertainty in this case? This is the first question.
Well, you have to take care of what the data tell you. If you have cause data, you have information on the cause grid. But if you want to have a look into local specifications, and in particular with respect to soil differences that are local, you need to have these data downscaled. But as I said, you should take the uncertainty into account, that something severe happens and not that it is smeared out and you believe this is all the information you need.
Okay. Is there any suggested approach to merge the data from weather stations and satellite data to have a better global data set?
Yeah, well, we do have the reanalysis, and this is really an asset that should be used with caution, because it is not the whole truth. In particular, if you have too little ground truth information included into the reanalysis. So you have to check them with local data, and even there you have to do downscaling approaches.
Okay. We have a question with lots of acronyms, and I'll read it as it is and try to help me. It's from Dr. Nashwan. Most studies shows the RCP 8.5 have the worst impact on climate, but what is the link likelihood of SSP 8.5 compared to sustainable scenarios like SSP 1.9? I hope you got it.
Okay. I did show results that are from a certain level of the scenario development. So there is a constant development, and this makes the different names. In the end, they all show, say, strong increases of greenhouse gases or moderate or weak ones. That's the main message there. And the questions, what is reachable, is related to the 2 degree or 1.5 degree question. In the end, it depends on what we as people and peoples are reaching in terms of getting the emissions down. And we need to do that, and everybody knows. But there are other aspects, and it is long-term that makes things difficult, right?
Okay. Another question from Professor Ahmed Abdel Hafiz regarding the decrease of its excessive in Germany. Will Germany decrease its excessive consumption of fossil fuel to combat climate change, since it's one of the main leading countries of climate change, of fighting climate change?
Yeah, indeed we are. We are on the process, and we are not just in the process because of the energy crisis we are facing currently. There is quite a lot of being done. For example, I just take an example out with respect to traffic. There is a change of the mobility towards electric power in order to have renewables being used there. I would wish there is a stronger move to hydrogen power, because you cannot have electric power everywhere. So there must be a good technology and a widespread of the hydrogen-based mobilization, addition to public transport, by the way, which I see with pleasure that you in Cairo are really working on that.
Thank you very much, Professor Uwe.
Thank you.
We're having now a short break. For the next session will be a panel discussion. So a short break for 5 minutes, and we will be back here. Thank you. هيبقى هنا غالبا. طيب حاضر. هنا في المكان. اوكي. اوكي.
مش البانر تحت جاهز؟ طب ما ناخدها تحت. ايوه البروفيسورز تحت يعني.
طيب. We would like to invite the German and the Egyptian professors and the panelists for a group photo with Professor Meteni. So it will be downstairs here, if you could join us. طيب. ممكن تخلي دي معاك وهرجع اخدها منك تاني؟ خليها زي ما هي مكتوبة. حاضر يا دكتور. امسك
Hello, this, hello.
is very rough because if we compare the
in the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute shortage of water. In the middle of a region where we have acute.
Now the panel discussion. Would you please take your seats and turn off your mobiles? Now the panel discussion. Would you please take your seats and turn off your mobiles? Now the panel discussion. Would you please take your seats and turn off your mobiles? Now the panel discussion. Would you please take your seats and turn off your mobiles? Now the panel discussion. Would you please take your seats and turn off your mobiles? Now the panel discussion. So, following to the interesting talks that we have been listening to the past few minutes, we will start now a panel discussions that we have been eminent professors teaches on journey, and we will start now a panel discussion that we have been adding to the speakers that we have listened to, and we will start now a panel discussion that we have been adding to the speakers that we have listened to, and we will start now a panel discussion that we have Minister of Water and Water Utilities, and he was as well the former governor of Cairo, chairman of the holding, former chairman of the holding company, as well water and government of Cairo, chairman of the holding, for joining us, as well as Professor Noha Samir Dunya, professor of environmental hydraulics, Dean Faculty of Graduate Studies, and professor of environmental hydraulics, Dean Faculty of Graduate Studies, and environmental hydraulics, Dean Faculty of Graduate Studies. We're nearly having like a 30 minutes panel discussion. Nearly having during the discussion, if you have any questions, send it on. Nearly having during the discussion, if you have any questions about send it on. And during while writing the question, if you're addressing the question for a specific professor, just write during while writing the question and after this talk, I will be having a coffee break and each after this we'll be splitting into having this the coffee break will be in the ground floor, and then after the coffee break we will start in the ground floor, and then after this coffee break that will be running for 1 hour, something like that, 1 hour and a half, and by the end of the working course we will come back here 1 hour and a half, and by the end of the working course we will come back here. So this is the plan of the day for the coming hours, and hope that this is the plan of the day for the next coming hours have been started. So I'll start by just an overview of the start had this morning, and I would just ask Dr. Nawi to give us maybe his opinion about we have witnessed during the talks examples of best practices in different parts of the world, use of technology, challenges of the lake of data. Based on your experience as a researcher and a policymaker, what are based on your challenges and opportunities taking what are the from the union to the what are the people
Ashraf. Ladies and gentlemen, thank you, Mr. Honor and pleasure to be with you today. Very happy to thank you, Mr. Honor, discuss very important subject. Thank you, climate change and its effect. Very important. First of all, I'd like to welcome our German friends. We are very happy to have you all with us today. Really, we're very happy to have you. Thank you about your day. Very nice. Great radio presentation, which we learned a lot about your day. And I think it's many things in radio presentation apply. And I think it's many things. I will never forget the support I got from the German. I will never forget 2004 up to 2011 when I was the chairman of the holding company and we started the reform of water and when I was the chairman of the holding company and the German government supported us technically and financially through GI. The German government supported us and gave them GI. Really, we appreciate your support and your help and gave them like really appreciate the support in the other very important subjects serving the support 100 million other very important sanitation serving very important issues. But I think very helping us, working with us in the support and the candidates, climate change, because we are very, very affected by climate change, because we are water, especially the water. For sure, we will have a water crisis. We will have a water shortage. For sure, in my capacity, we will have a water shortage as a minister. In my capacity, very professor, I see the only minister big challenge for his water resources. I see the only minister big challenge and water resources. I will take Dr. Abu Hadid mentioned a lot of things in agriculture. We use the water. Abu Hadid mentioned a lot of things in agriculture. We use the water. Abu Hadid mentioned a lot of drinking water. For sure, we will face problem. Drinking water for sure, water shortage face also problem with the increase of population and increase of water shortage. The consumption of drinking water will increase of population and increase of water shortage. We have consumption of drinking water will increase of population and increase of water shortage. We have consumption of drinking water will increase of population and increase of water shortage. We have consumption of drinking water will increase of population and increase of water shortage. We have energy consumption and the pollution we got from the price. Energy consumption. We would like to see a joint research we got from universities and ancient. We would like to see or joint Egyptian university that we can overcome this problem by joint Egyptian university that we proposing another system for the salination and proposing a way that we can use the salt from the brine and proposing a way that we can reduce and use from the brine. I think if we can solve this problem through joining research, we can solve our universities. That will solve joining the big problem which we are very serious. That will solve. I think from the 5 speakers we listened this morning, I think from the 5 speakers you present very good. I think from the 5 which we can apply, you present very good. I think to protect our country from which we can apply climate change. I think we have to go more deeply into climate change, and that I think we can work with that during the climate change. We can work with that during the
Thank you very much. Clearly highlighted the importance of collaboration and research. Thank you very much. Clearly highlighted one side collaboration, especially the comments that were given as examples of different parts of collaboration, especially the ones that we're having here in Egypt, and maybe especially you could highlight on this Professor Mateni mentioned that there is a book you could highlight on this the studies that were done in the research center, and so I'll give you the mic and maybe I'll ask you what are the chances of collaborations and the area what are the chances of collaborations and the area
I have worked in Holland. My study was in Holland, in ITC, in Enschede, near Germany, in Germany. My studying since 2003, near Celsius and GIS in Germany. My ITC here, and also the modeling. So I am very interested in your subject. I hope that we will see the modeling. So I think capacity building in our own university. I hope that this subject, especially environmental modeling and forecasting, and in our I try to make it in my. I am the dean of the Untitled Chapter and forecasters. We have environmental. I try to part with my. So I try to make this research in our faculty. But until now, this is a few research in our area, especially application of modeling and remote sensing and GIS in environmental area. So it is very interesting topic, modeling exchange together, maybe